Hi all, welcome back to Whoops with C++ session 33. In last session we have seen how to use new delete and what is dynamic memory allocation techniques in C and C++. So today also we'll discuss little more about the pointers. Okay, so then just focus about what is pointers in C++, why it is used, how it is used. Okay, now just talk about how to create pointers to inbuilt data types. What will happen if I create a pointers to an inbuilt data types? So for this, just observe this code. Uh, in main function, I have one variable called int a and a equals to 10. So when I say int a equals to 10, what is happening is here I am declaring the variable a and assigning the value 10 to a. So this a will get memory in stack segment. And when I say to how can I access this variable, if you want to assign, you can say a equals to 10, and if you want to print the value of a, what you can do is you can write it like this: cout a endl. So then a value will be printed. Now I'm taking one pointer int star ptr1 equals to address of a. So these pointers are special type of variables which will hold the address of the same type. Means if the ptr1 is integer pointer, then it will hold address of an integer variable only. Okay, now int star ptr1 equals to address of a. Now this ptr1 is holding address of a. Now how to access this how to access this value, a value? You can access in two ways: either you can access cout a or cout star ptr. Okay, so because ptr is holding address of a. Now in the same way, what we are doing is we are trying to create the variable in heap segment. Just see the pictorial representation how it will be. Okay, now let's take a stack memory. Okay, so in this stack memory, when I say int a, what is happening is for this a, now one memory location will be allocated in stack segment. Okay, now we are assigning the a value as 10. So 10 value will be assigned. Okay, so now if you want to print a value, then cout a, it will print cout a, it will print this 10 value. Now what we are doing is, after this we are trying to create a pointer variable and we are trying to give the address of a. So this is address of a is just as in 0x1000 is the address of a, and this variable can also, this 1000 memory location can also be referred as a. Okay, now let's say ptr1 I have created, and ptr1 is a special type of variable which holds the address of another variable of same type. Okay, now it is also present at some memory location, say 0x1004, and ptr1 equals to address of a. What is address of a? Address of a is 1000. So this 1000 will be the value of this ptr1. Means, so it is pointing to this memory location. Since it is a pointer, it will point to the same memory location. Now when I say cout star ptr, so how the compiler will extract this one is, what is the value present in ptr? Okay, so what is the address present in ptr? That is 0x1000. So in 1000 memory location, what is the value present? That is 10. Okay, so now here we'll get the value 10. So this 1000 memory location is also referred as a, and it is also referred as star ptr1. So you can access this value in two ways: either you can simply write cout a, or you can write cout star ptr through pointer or through this one. So here it is ptr1, not ptr star ptr1. Okay, so now this variable is created, this inbuilt variable is created in stack memories, and it is also referred with the value a. In the same way, what I want to do is, I have a requirement, I have to create this variable a, means integer variable, in heap segment. Okay, so for that what I'm doing is I'm creating one pointer in star ptr2, that is ptr2, and ptr2 is created, and some address will be given to this. Now for this ptr2, so this ptr1 is holding address of variable, which address of integer variable which is present in stack segment. Now what I want is, I want to hold an integer variable which is created in the heap segment, and I have to hold that variable address. So for this, what I'm doing in star ptr equals to new int of 100. When I say this, then immediately in heap segment, or in heap segment, one variable will be created, integer variable with some memory location, say some memory location 0x2000, and what is the value we are giving, that is 100. So 100 will be given this. So once the memory location is created here and assigned, then it will be given to this ptr2. So now same, whatever address is there, this 200, that 2000, that will be given here. Now the ptr2 is pointing to this memory location. Okay, now if you see, ptr1 is also pointer, ptr2 is also pointer, both are pointers only, but ptr1 is holding address of a variable, integer variable, which is created in the stack segment. ptr2 is a pointer which is holding address of a variable which is created in the heap segment. So for the stack segment variable, we have another name called A. But what about heap? So we don't have any other name for this. So if you want to access this value, you have to use ptr only, pointer only. So if you want to access stack variables, then you can use the another name, reference name is the right, that you can use. But what about the heap memory variables value? You have to use pointer only, cout star ptr2, then it will, this will print this value. Okay, so whenever you are using heap segment, you don't have any option, you have to use pointer to access the values present in that, or to initialize the values present in that memory location heap. So heap means you can operate the heap with the pointers only. Okay, now, so as we already discussed, when you are allocating memory in the heap segment, then this is user responsibility to deallocate that memory from the heap segment. Otherwise, your programmer won't take the, it is our responsibility to free it. It won't be automatically freed. Okay. Now, for that reason, what I'm doing, delete ptr2. So why only ptr2? Why not ptr1? ptr1 is holding address of a local stack variable. So delete ptr1 is not required, but delete ptr2 is required. Why delete ptr2 is required? Because it is allocated memory in the heap segment. Okay, so for this, memory is allocated in the stack segment only. So delete ptr1, if you are doing it will throw. So it is not allowed. Okay, not required. Okay, so now let's see, you can try what will happen if you do delete ptr1. That is an assignment, you can take it off. Okay, so now let's see what will happen if you do delete ptr2. So then immediately the memory in this heap segment will be removed. Okay, removed. Now what will happen if you see still this ptr2 is there, some value is present here, 2000, means wherever it is previously pointing, same memory is there. Now at this particular point, after this line, at this particular point, this ptr2 is a dangling pointer, means it is pointing to a memory location which is already freed. This is called dangling pointer. Okay, so while dealing with the dangling, you have to be very careful while dealing with these pointers. You have to cross check whether it is a dangling pointer or not. Okay, so if it is already freed, make it, this pointer is pointing to null. So since after this we don't have any line, no other statements, I have not mentioned ptr2 equals to null. Okay, so ptr2, now it is a dangling pointer. If you are trying to do cout star ptr2 here after delete ptr2, then segmentation fault will come. Okay, so now after this line, slowly that heap segment gone. Okay, so ptr2 will be removed from the stack frame, then ptr1 will be removed from the stack frame, and then variable a will be removed from the stack frame, and stack frame will be closed. Okay, this is with respect to inbuilt data types. Now then let's talk about pointers for user defined data types. Okay, now observe this class. I have a class called cEmployee, and there is one pointer variable in star empid, and I have a constructor and display function in the public sector. So constructor, what it is doing, constructor, it is I have taken the default argument constructor int id equals to 100, means if you are passing the argument while creating the object, So then it will take the value. If you are not passing, then it will take default value. This is the default argument constructor, which will works like both zero argument as well as parameterized constructor. And here I am displaying cout star emp id. Okay, so here for this emp id is a pointer. For this pointer I am allocating memory in the heap segment. Okay, now in main what we are doing, we are creating an object cemployee object1, means this object1 will be created in the stack frame and we are displaying this value. In the same way I want to create an object in heap segment. Okay, and so that heap segment means I have to use the pointer. So pointer of same class I have to use ptr equals to use employee 1 or 2. Here obj1 is an object which is created in the stack segment, and another object I am creating which is in heap segment, but to deal with that object I need a pointer. Okay, so for to display the objects information I am using obj1 dot display, but here to display heap segment objects information I have to use ptr arrow, and as usual we have to use delete ptr to deallocate memory. Okay, now let's see what will happen step by step. Okay, so now let's start take two memory segments, that is stack memory and heap segment. Okay, when I say see employee obj1, the first step is object creation. So in the object creation, first memory will be allocated this object. How many bytes? Totally 4 bytes, because we have only one pointer attribute, that is empid. Now for this, once the memory is allocated, then the very next step is constructor calling. So what is there in the constructor? See employee int id. So is I am passing any values? No, I am not passing any values. So the id value is 100. Now what will happen is emp id equals to new int id. So for this pointer, now this is a pointer. For this pointer, I am allocating memory in the heap segment. Okay. So first in the heap segment, memory will be allocated new int, okay, 100 and 0x2000. This is the address. Once the memory is initialized, then now this address will be given to this emp id and it is pointing to this. Okay, so this now the object creation is completed. Okay, so this is a pointer attribute, it is holding address of the variable, integer variable which is created in the heap segment. Now the second next what I'm doing, obj1 dot display. What is there? Cout display, cout star emp id. Emp star emp id means value present in this address is 100. Okay, so that 100 will be printed here, so no problem till now. Okay, so next what I'm doing, I am creating a pointer c employee star ptr. So when I say that one, first ptr pointer variable will be created and it is having 4 bytes. Now for this pointer I am trying to create an object, this object, some object in heap segment. So as usual, first what is the step? First object will be created, memory will be allocated for this object, say emp id 0x210. Assume this is the address. See, for this object whichever is created in the stack, for this object we have a name obj1, but the object which is created in the heap segment, for this we don't have any name. Okay, so now the object is created. So as soon as object is created, memory allocation is done. What is the next step? That is constructor calling. So now as we have already discussed that new will always call the constructor for the constructor when you are using with user defined data types. So what is the constructor? See employee, and here we are passing the value 102. Now the id value is 102. Let's say now emp id equals to emp id, this emp id equals to new int id. So what we are doing again, for this emp id we are creating memory in the heap segment. Okay, so memory got created. Okay, 102. Now this address will be given to this 0x2200. Now it is pointing to this. So all are present in the heap segment. So once the construction is completed, object creation is completed successfully in two steps, memory allocation and memory initialization, both are completed. Now this 0x2100 value will be given to this pointer. Now this is a pointer which is holding two objects. Now how many objects we have created? Totally two objects. One object is created in the stack segment and another object is created in the heap segment. Okay, Now, for the stack segment object, we have a name called obj1. For the heap segment object, we don't have any name. We have to access it through pointer only. So if I want to display these values, what I'm using obj1 dot display. But if I want to display the values of this, what I have to do? PTR arrow display. Till now it is not an issue. Now we know that we have to use delete operator whenever you are using new operator. Okay. So for PTR we have used a new delete operator. PTR equals new. Now PTR equals to arrow display, then delete PTR. Right, correct. Now what I'm doing, delete PTR when I say first memory. What is their PTR? PTR is having 0x210. So this memory will be freed from the heap segment. Very good, done. Okay, so now what is this? Now this is still, now it is a dangling pointer, it is pointing to the freed memory location. So once it is done, what will happen? So PTR will be removed from the stack frame. So after that, obj1 will be removed from the stack frame. So next, the stack frame will be removed. Then what about this heap segment? We have two things, right? 220, 10, 100 and 102. 100 is for the first object and this 102 is from the second object. So what is happening here? Memory leakage. Then how to avoid this? Okay, this is where the concept of destructor will come into picture. Okay, so destructor will take care of the freeing of the memory. So what destructor and how to use the destructor we'll see in the next session. Okay, now a few of the points you have to remember here. So pointers are special type of data members which will hold the address of other variables of same type. So means if you are creating an integer pointer, it will hold integer value address. If you are creating a C employee pointer, then it will hold the address of a C employee object. If you are creating character pointer, it will hold the address of character variable. Okay, but going for you can do the casting also, but you casting also we can do it, but this is the actual thing. Okay, now pointers can hold address of a stack variable as well as address of an heap variable. So like int equals to address of a we have given, as well as so ptr1 equals to address of a we have given, and we can also say ptr1 equals to new int of 100, like that. So we can hold, it can hold the address of a heap variable also. So to hold the address of a variable of heap, we need to use new operator, and to release the memory from the heap, we need to use delete operator. So once we free the memory of the pointer the pointer variable still pointing to the same freed memory location. So we have seen once you do delete operator operation also, it will be pointing to the same memory location. So the pointers which are pointing to already freed memory locations are called as dangling pointers. Okay. So that is the reason once you have deleted, if you are no longer you are using that pointer, means once you have done the deletion, then you make sure that PTR equals to null you are assigning. Means it is not pointing to any memory location. Okay. So while dealing with user defined data types and its pointers with heap memory, new operator will always call the constructor of the same class. Okay, to free the memory location, delete will call the destructor. So we have seen, right, we have seen memory leakage. How to avoid that memory leakage? By making use of destructor. So if you are not dealing with some freeing the resources during object destruction, then destructor is not required. But if you have to perform releasing some resources when the object is going to destroy, sorry, you have to use destructor. Okay, so that's for today. Hope you have understood the concept today. In next session we'll see how to use destructor, how to write, and its usage. Okay, yeah, thanks for watching.